Please welcome Coraline, Ada, Ehmke.
Hi, everybody. I judge the success of a talk by how many tweet mentions I get. So, Coraline, Ada, please be kind and please be in English. I've been a web developer professionally since 1994. I built my first website in 1994, Paradise Lost. And I don't know if you can see, but it was one of the top 5% websites in the world. Thank you. I've been doing open source since 2004. In 2016, I won a Ruby Hero Award. I'm a founding panelist on a podcast called Greater Than Code, which I encourage you to check it out. I am most well known for being the creator of the Contributor Covenant, an open source code of conduct adopted by over 40,000 open source projects, including all of Google's open source, all of Apple's open source, all of Microsoft's open source, JRuby, Bundler, and Rails. I'm also working on a book called The Compassionate Coder, which is about the practice of empathy in software development. If you'd like information on it, compassionatecoder.com, and you can sign up for our mailing list to keep up to date on developments in the book. So this is my first time in Paris, and I've been taking in all the sights. I found that the locals are extremely friendly, and I'm learning how to understand important French phrases like "Voyez-nous pas caresser la crâne?" Do not pet the skulls. I probably butchered that. I've been tweeting about the things I've learned about France as a tourist using the Francia Facts hashtag. This is something I do with every country I go to. So many Parisians get around on the city on scooter. This trend began when in 1987, Parliament outlawed the ponies that were so popular until that point, following the manure crisis. Okay, I'm here to talk to you about aesthetics and the evolution of code. As programmers, we're captive to the notion of elegance. We talk about elegant code, but what do we mean by it? One of my favorite children's books, Alice in Wonderland, has a scene with Alice and Humpty Dumpty. And Humpty Dumpty says, when I use a word, it means just what I choose for it to mean, neither more nor less. The question is, says Alice, whether you can make words mean so many different things. The question is, replies Humpty Dumpty, which is to be master? That is all. Well, it just so happens there's an actual entire science devoted to understanding beauty and elegance, and we're going to explore it a bit today. It's called aesthetic theory. Aesthetics is a study of how we experience beauty. Aesthetics is usually defined as a sensory appreciation of beauty, but the appreciation of beauty can also be a cognitive phenomenon. There are 4 theoretical approaches to aesthetics. The first is pluralism, which states that every person perceives things differently and derives different meaning from an experience. Therefore, there is no absolute truth in perception. An example, through the pluralist filter, if 2 people are looking at something blue, they're both experiencing a unique color. There is no universal blue. Hybridism. In hybridism, perception and meaning derive from a rich common experience, and the common representation is truthful. So with hybridism, we might say, everyone looking at the sky sees just about the same blue. In absolutism, aesthetic beauty derives from truth and provability. Because the wavelengths of light reflecting off an object, we all perceive it as blue. This school of thought emerged from applied aesthetics, and according to Dijkstra, is the only one that applies to mathematics and therefore to software. Finally, eclecticism. Eclecticism promotes the idea of the application of different interpretations contextually rather than a single set of standards. With eclecticism, there are multiple paths to the truth. The effects of our aesthetic sensibilities can also be deliberate. This is called applied aesthetics. Think of physical things in the world. They have basic attributes pertaining to their physicality. We build structures designed to serve a utility comprised of materials with fixed costs. But when we build buildings, we don't just build concrete boxes. Through applied aesthetics, deliberately injecting aesthetic attributes, objects can be elevated to new dimensions, becoming not just utilitarian, but an expression and an experience. And this makes our interactions more pleasing. Both of these buildings serve a purpose, but one provides a pleasurable experience that the other does not. We want to be surrounded by beautiful things that appeal to our aesthetic sensibilities. This is Bacon's Castle. It's in Virginia in the US, where I'm from. It was built in 1665. It's the oldest documented brick building in Virginia. It's maintained by private and government funds as an historic site for the last 300 years. This is a 128-foot-tall flak tower built in Hamburg by the Nazis to protect anti-aircraft weapons and defend against bombing raids by the Allies. It's made of poured concrete. Hamburg has very, very, very expensive property values, but this flak tower is so heavily built that tearing it down would cost more than the real estate that it's on. It was built by the German architect Friedrich Thams, considered by many to set the foundation for a new architectural movement that in a post-war era would be called brutalism. We don't want to maintain applications that are monolithic and brutal, authoritarian, utilitarian code bases. We want to create small and elegant programs that interact with each other in predictable and pleasing ways. Both types of programs are long-lived. Ugly code bases are often too expensive to tear down, like that flak tower, while elegant code bases flourish and grow and are extended over time. And if we're lucky, we can choose the type of code base we create and opt for something elegant. Consider the open source ecosystem. Projects that are useful but are built in a way that makes them difficult to work with won't attract as many contributors as more elegant and aesthetically pleasing code will, and this is a form of natural selection. Unlike closed source, where we have to put up with long-lived ugly code, in open source, we get to pick the projects we contribute to. I mentioned natural selection, and I did that on purpose. I believe that code is subject to natural forces just like organisms are. Elegance is an aesthetic experience. It's about perfectly conforming to a set of imperfect standards. Elegance in code is a result of a mysterious process. Elegance in nature, I believe, is also the result of a mysterious process. And in nature, that process is evolution. Let's talk about some of the basics of evolution. We have genotypes. Genotypes are the genetic material defining the characteristics of an organism. Eye stalk height, or eye color, or fur patterns. Then we have phenotypes, which are the expression of the genetic information as a physical characteristic. Natural selection is a process by which traits become more common or less common in a population as the side effect of their impact on reproduction. A common example of natural selection, prior to the Industrial Revolution, forest moths were light-colored and blended in with tree trunks to protect themselves from predators. With the advent of the Industrial Revolution and the soot and other contaminants that were in the air, tree trunks got darker. So the naturally occurring darker-colored moths had a survival advantage and thus a reproductive advantage, and the forest moths that we have today are darker in color than those from 200 years ago. There's also artificial selection, where you deliberately breed for specific traits, and we do this with food and with dogs and with cats. But can aesthetics be a factor in evolution? In the US, we have a legendary figure called Johnny Appleseed. His name was John Chapman. He lived in the late 1700s. He ranged far afield and planted apple orchards from seed in areas that he thought were likely to be settled so that he could sell the orchards to settlers. He famously wore a shirt made of a coffee sack and traveled everywhere with bushels full of apple seeds. In the 1700s, sweet things were a luxury. Sugar was very scarce until southern plantations used slave labor to farm sugarcane. The only honeybees that occurred in North America were those that were brought over from Europe, so honey was very rare. Fruit was the only source of sweetness that was available to most people. Today we think of apples like this, but every apple tree that produces fruit for eating is the result of a graft. Early colonists brought branches with them to graft into natively occurring apple trees to produce edible fruit. If you take a red delicious apple and remove the seeds from it, plant it in the ground, water it, tend to it, let it grow up into an apple tree, you don't get a red delicious apple tree. You get a tree that produces fruit that looks like that. And that was the kind of fruit that Chapman's orchards produced because he planted apples from seeds. So was he stupid to plant orchards full of trees that yielded inedible fruit? No, because he wasn't interested in fruit that you eat. His kind of apples were perfect for making hard cider. Because of fermentation, hard cider would last longer than fresh apples and had the added benefit of being alcoholic. So his ugly orchards were quite valuable, and John Chapman was a pretty shrewd business person. Until the 1830s, when the temperance movement took hold, and apple orchards were in danger of losing their value and their viability. So apple growers turned to marketing. They started advertising the health benefits of the fruit. This is where the phrase, an apple a day keeps a doctor away, comes from. It's actually marketing copy from the 1800s. Apple orchard owners started experimenting with new varieties of apples, selecting and cross-pollinating those that produced good-looking, tasty fruit. Essentially, they were boosting evolutionary forces to produce something that was in line with current aesthetics. The genetic expressions of the apple have changed over the past 200 years in response to the changing aesthetic desires of the people consuming them. Precious branches were brought from Europe in the early days, but cider apples dominated until the mid-1800s. And by the late 1800s, there were literally thousands of varieties of apples being cultivated. Today, there are about 20. Whether we guide their evolution through crossbreeding or inadvertently do the same thing by selecting variations based on our aesthetic principles, we can have a direct effect on the evolution of things in our ordinary lives. Are aesthetics an integral part of evolution or an outside influence imposed by humans on the natural world? We can answer this question by asking, what do genes want? You may have heard of a popular book called The Selfish Gene. It actually was inspired by a book called Adaptation and Natural Selection by George Williams. His central tenet was that since evolution occurs through the survival of competing genes, natural selection and evolution are best considered from the perspective of genes instead of the perspective of organisms and species. One of the interesting examples of selfish genes is called the green beard effect. Imagine a gene that produces in males of the species the ability to grow a green beard and also brings with it an urge to be nice to other men who have green beards. This can be thought of as genetic self-identification. A gene in one individual provides a benefit to another individual that has that gene, but because two green beards can't reproduce, the genes are selfish. They're benefiting themselves without regard to the fate of the organism. The green beard effect manifests in technology as a tendency to stick with one language and even the development of communities around a given language. And it's important to understand this isn't just for our own benefit. It's more beneficial to the language than it is to us. We are not the ones who are in charge. Technology is playing a different game. So if we apply the notion of the selfish gene to programming languages, we can ask ourselves, what does code want? Code wants ubiquity. Technologies want to dominate their ecosystems. They want to be everywhere, on every device, from your phone to your computer to your coffee maker. Universality. Technologies want to be applicable to as many problems as possible. Consider the notion of the API. APIs have evolved from RPC to SOAP to XML RPC to JSON to GraphQL. The concept of an API is generally the same, but its expression, its phenotype, has changed to help the idea survive. Code wants longevity. It'll do everything in its power to live as long as possible. Consider Unix, one of the most successful computer programs ever written, and its underlying philosophy of simple components and an openness to new protocols. That gives Unix evolutionary advantages. How does code get what it wants? By being flexible. The flexibility of a given technology or language encourages specialization, reducing the cost of sticking with something that you know. By being extensible, meaning the language can be used for novel applications. Ruby was initially designed as a sysadmin language, and look at what it became. By being novel, adding new language features, supporting new methodologies, new coding techniques, These are ways that existing technologies keep up and keep us engaged and excited. And on the darker side, programs get what they want by becoming entrenched. The fallacy of sunk money. If you're a gambler and you've been on a losing streak, but you've lost thousands of dollars already, you're like, this next hand, I know I'm going to win this next hand. And that same thing plays out in technology when something becomes too expensive to change, or when your code has its tentacles in every other system in your business. Is it fair to compare natural selection and evolution in the natural world to programming? Do the concepts even map? If you think about it, languages are like the genotype. They define and provide access to the allowable features and functionality accessible to the programmer. Expressions of the potential of a language are kind of like the phenotype. There are environmental pressures. Code has to perform and compete in a highly interconnected environment. There are physical and logical platforms, operating systems, infrastructure, protocols, and of course survival on the internet at large. The competitive environment makes us think of natural selection. And finally, artificial selection in deliberate intervention in evolution is like refactoring and active support and maintenance. The functional equivalent of a generation in a program is a version or a cycle of attention. Artificial selection in a technology sense is a guided evolution brought about by maintenance and support, following a roadmap and keeping a technology current and relevant. We've seen how aesthetics can affect genetic expressions in organisms. Can the same thing happen with algorithms? And how can we judge the aesthetics of a programming language? I believe there are four main ways we interact with a language: writing source code, exploring documentation, reading source code, and interacting with the REPL or command line. So we have semantics. Semantics comprise the syntax, keywords, methods, and the metaphoric design of a language. We have the command line, the ability to launch programs and interact with them through an executable environment like console or IRB. Documentation, how well documented language features are and how accessible the documentation is. And finally, readability, how readable source code is, how easy is it for a developer to reason about how a program operates. I conducted a survey a couple years ago of 6 languages and used 5 factors to evaluate the aesthetic appeal of those languages based on those 4 criteria. And I used that data to feed an algorithm I call the aesthetic index. Python came out with the best aesthetic rating, followed by Ruby, followed by JavaScript, C#, Java, and PHP. And I thought it'd be interesting to map those aesthetic ratings of the language to how popular they were. And there is, in fact, a confluence. With the exception of JavaScript, which has no real competitor in the client-side space, there was almost a direct correlation between the aesthetic qualities of a language and how popular it was. So that's languages. What about the aesthetic qualities of code, the phenotype in our evolutionary example? I think there are 4 basic interconnected aesthetic principles involved. The first measure is correctness, which falls into the absolutist sphere of aesthetics. But I don't think correctness alone is enough to make code elegant. And I have to pick on Dijkstra a little. Dijkstra believes that programming is an extension of applied mathematics and that the beauty of code arises from its correctness. A couple of years ago, when I started dabbling in AI again, I came across a book called Clever Algorithms. The premise hooked me immediately: nature-inspired programming recipes, a handbook of standardized algorithms derived from natural systems, and it was written in Ruby. I was so excited. The only way it could have been more perfect for me is if it were delivered by Douglas Hofstadter riding on the back of a raven. Then I opened the book, and I found things like this. Methods called drand1ben with a signature 15 arguments long. Yuck. Or this beast of a method, which goes on for no fewer than 118 lines of code. And all the examples in the book were like this. It was all procedural code. There were not any objects at all. And this book was written by a PhD in applied science and a noted AI expert. It's apparent to me that elegance and correctness are not correlated. The second aesthetic measure is performance. I consider performance to be best understood by applying a hybrid perspective, because while performance can be measured precisely with benchmarking tools, it's not the benchmark value, but rather the experience of performance that is important. If you optimize a query from 100 milliseconds to 50 milliseconds, your end user is not going to care. But that same percentage improvement in page load speed is going to be very well appreciated. The third aesthetic measure is brevity. This is best understood by the eclecticism filter. We instinctively recoil from bloated controllers, user models with thousands of lines of code, and deeply nested conditionals. This reminds me of Blaise Pascal's apology. I wrote you a long letter because I didn't have time to write you a short one. But brevity can negatively impact readability. Readability is absolutely subjective. But it's important to note that we write code for humans first and computers second. We need to write for a particular audience. And I would posit that unreadable code is just as expensive as incorrect code. We use style guides and tools like Rubocop to quantify and enforce aesthetic principles. We favor short methods. We should favor lines of code that are less than 80 characters long. I think these four qualities combine in some mysterious way to create an aesthetic experience of code, a sense of what we call elegance. I had a conversation with a friend about this, and the question arose as to whether we could actually quantify elegance. Applying my four measures, we could lay them out on a grid. The four measures: correctness, performance, readability, and conciseness. We want to maximize the area of the graph, optimizing for balance and symmetry in these four dimensions. The y-axis encompasses correctness and performance, which are utilitarian concerns, and the x-axis covers how concise and readable the code is, which is more of an aesthetic concern. As an example, this code is relatively balanced between correctness and performance, but not as concise as it could be. This example sacrifices readability for conciseness. Code that favors readability can still be performant and correct, but this is the goal that we aspire to, a balance between all four aesthetic measures. Why does all this matter? Albert Einstein wrote that after a certain level of technological skill is achieved, science and art tend to coalesce in aesthetic plasticity and form. The greater scientists are artists as well. Are we allowing ourselves to be artists? Are we allowing ourselves the freedom to create elegant code? We want to build this, cathedrals of code, elegant, timeless. But often our bosses want us to build this, quickly constructed brutalist monstrosities with no aesthetic appeal at all. Maybe we should ask ourselves, why do we write code? Do we do it just for money? Do we do it just for job security? Or do we do it because it's something that we love doing, that we're passionate about, because we're attracted to the infinite potential of solving problems by creating something out of nothing? Who do we write code for? Interpreters, compilers, stakeholders, users? I think we primarily write code for other developers, and we have to consider their aesthetic sensibilities, not just our own. We have to be flexible and understand that elegance is subjective, but we need to care about the experience that other people have when they read our code, debug it, or extend it. Why do we care about quality? Is it just a matter of maintainability and extensibility? Or is it the fact that our names are on our commits? We don't want someone down the road to blame a piece of code and start calling us names or thinking poorly of us. We care about quality because the code that we write is an extension of ourselves. We are not our code, but code is an expression of something that we are. Aesthetic appeal is a measure of quality, perhaps one of the most important measures, not necessarily to stakeholders, but to the people who really own the code, the developers. Architecture without aesthetics is brutalism. Code without aesthetics is a commodity. Maybe some people are comfortable getting paid to write crappy code under bad circumstances for a big paycheck, but I'm not among them. So don't do it. Care about your code. Recognize the needs of your code and respond to it. Create a symbiotic relationship with your code. Guide its evolution and allow yourself to evolve in the process. Consider the experience of writing code and reading code. We have the power to decide what form our code will take. Code wants to be universal, ubiquitous, is willing to be flexible to ensure that we stay engaged as it evolves. We can participate in this process blindly, like the moths, or we can actively and intentionally engage with our code and create experiences of pleasure for ourselves and for others. In the end, it's our responsibility to tend to our code orchards to make the fruit of our labor beautiful and delicious. Thank you.
Thank you so much. Any question?
Okay, yeah, thank you for this talk, very inspiring. Do you have kind of a way to, okay, let me rephrase that. When you're in your day-to-day life, day-to-day programming life, you sometimes don't really feel the moment when you're stopping building cathedrals and starting building things like dirty buildings. And do you have a way to, I don't know, some tricks or some methods to stay focused and make sure that you don't slide to this path of like following what your boss is saying and staying in a company that do not allow you to keep the aesthetic or the artistic nature of your work?
I want to be really clear. We still have to deliver code, right? We still have deadlines. But I think that we write better code when we go slowly. We introduce fewer bugs when we go slowly. But we have deadlines, right? So my advice to you, if you feel like you're being put under such pressure that you cannot write your best code, is to do something that children learn to do at a very, very young age in order to get their way. And that is lie through your fucking teeth. If you're asked how long it will take to implement a feature, double your estimate. Lie about how long it will take. That will give you the appropriate amount of time to craft code in a beautiful way that also is easier to maintain, has fewer errors, and is better for other developers on your team. So lie. And slow the fuck down.